All right, let's look at these things. First of all, the types of parts of the circle. Two radii. Radii go from the center to the point outside. So segment, they need to be segments. Make sure you put the line marker on top of them, or the segment marker, I should say. OB and OT are the two radii. A secant is the line that goes through here. It's a line, not a segment, because that would make it something else. The tangent intersects the circle at exactly one point. That's this one, point T. And so the tangent is line TS. You can name that a ray or a segment. It doesn't really matter how long it is. The diameter is segment BT. Two chords. That's what segment AB. That's the difference between the secant is the line that contains segment AB, but the chord is segment AB. And then the diameter is also a chord. Diameters are chords. The point of tangency, it's point T where the tangent intersects. Now, we didn't learn this actually, but it snuck in here, this question. A lesson we didn't learn is that a tangent line and a radius form a right angle, but that's the answer there. You had no way of answering that unless you just guessed really well. All right. When you have a triangle formed by two radii and a chord, it makes an isosceles triangle because the radius is equal to the radius. So the three angles of this triangle, 180 minus 102 leaves me with 98, divided by 2 is, or 78 rather, is 39. Number 9, it's the same thing, that's an isosceles triangle, but because that's a 60-degree angle, that leaves 60 and 60 for these two congruent angles. So this is an equilateral triangle, therefore x is 5. Same opportunity here. If that's a right angle, these two angles have to end up being 45. Therefore, this is a 45, 45, 90 isosceles right triangle. 9 times the square root of 2 to get to the leg to the hypotenuse. This one's a little bit different, but it's kind of simple. The radius is equal to the radius. So if this radius is 5, so is that. If this radius is 10, so is that. So OP has to be 5 plus 10, 15. Number 12, because of this major arc is 315 degrees, that minor arc is 45 degrees. The central angle is equal to the minor arc, 45 degrees. Several ways we can get x from here. We can consider that this is a semicircle. That's a diameter, so this is a semicircle. So this whole arc here is 180. Therefore, this arc here has to be 55, 55 plus 25. Or we can figure out that this angle here is 125. Those angles are supplements, makes a straight angle. We get 55 from there either way. On the questions like 15 through 26, really, it's kind of silly that they ask so many of these. But if this angle down here is 128, this arc is also 128. This angle is 90 degrees. This arc is also 90. Now, the key to this is that this guy right here, TD, is a diameter. So therefore, this is a semicircle, 180 degrees. So 128 plus 52 is 180, 90, and 90. Now, that I have all of those things there, they can ask me all the questions they want. We just got to put the pieces together. So for example, arc CBD, it starts at C, it travels through B, and ends at D. So that's 120 plus 90 plus 90 is arc CBD. Or it's 360 minus 52. But you can put all those things together however you want. All right, the area of a rhombus. The formula for an area of a rhombus when it deals with diagonals is 1/2 times the first diagonal times the second diagonal. Now, the mistake people have been making, they've been saying 1/2 times 6 and 1/2 times 9. It's 1/2 times this entire diagonal, which is 12, and the other entire diagonal is 18. So it's 1/2 times 12 times 18. Gives us 108 in this case. All right. Number 28, that's a triangle. So 1/2 times base times height. When you have a right angle, there is your base and your height. The height, of course, has to be perpendicular to your base. It doesn't matter which one is which. So it's 1/2 times 3 times 5. I guess I didn't finish that. Hold on. So yes, it's 1/2 times 3 times 5 is 7.5 yards squared in this case. This is a trapezoid. The formula for the area of the trapezoid is 1/2 times the sum of the bases. Some of you have been multiplying the bases. There's 1/2 times the sum of the bases. My bases are 9 and 19 in this case, times the height. Well, it gave us the height. We don't have to do anything other than plug in the 9, the 18, and the 12 in and simplify. It's 168 units squared. Number 30 is also a trapezoid. My two bases, well, base 1 here is 11. Base 2, we got to figure out a little bit. My height, look, there's my right angle connected to the bases. it's 8. My height is 8. We just got to figure out what this missing piece down here is. That looks like a rectangle to me, so that makes that whole B2 equal to 17. 112 is what we get. Remember, add, don't multiply. Okay, next. The area of an isosceles triangle, 5, 5, and 8. The altitude is what we need. My base of my triangle is 8. We need the height. That altitude, that height also splits the base in half. Now I got a 8 squared plus 4 squared equals 5 squared. That's a 3, 4, 5 triangle. So now it's 1/2 times 8 times 3 is 12 units squared. An isosceles trapezoid. This one's pretty important. You're going to see this for sure. So the legs go here, the bases go here. If it's an isosceles, they got my two bases. We just got to go use the height. This is where we have two congruent triangles and that rectangle in the middle. This 10 up here comes down to another 10. What's left? 18 minus 10 is 8, so these two pieces have to be 4 and 4. Now it's something squared plus 4 squared. This looks familiar. That's 3. Our height is now 3. I made a mistake. Hold on. There we go. It's 42 units squared. 1/2 times 28 times 3. Equilateral triangle. If it's equilateral triangle, you've got 60-degree angles. Each side is 12 if the sum is 36. That height splits that 12 in half to 6 and 6. That's a 30, 60, 90 triangle. My height here is the long leg of that 30, 60, 90 triangle. That's going to be 6 times the square root of 3, short leg to long leg. The perimeter of the square is 44, therefore 11 all the way around. The diagonal chops it into 2 45, 45, 90 triangles. So from the leg to the hypotenuse, which is what we're solving for, is multiplying times the square root of 2. If a circle has an area of 400 pi centimeters squared, then the diameter is what? Well, the radius is going to be, the radius squared, where my arrow goes, the radius squared is 400, so the square root of 400 is 20. The radius is 20, therefore the diameter is 40. So yeah, that came from this. R squared equals 400, so R equals the square root of 400, which is 20. And then I have no idea how to do 36. Good luck. All right, talk to you soon. Bye.